Okay, now what we're going to do is we're going to find the horizontal and vertical components of a vector. And what they're doing here in these two examples is they're giving us an angle and they're giving us a magnitude. So let's just draw a sketch of what it is that I'm talking about. So suppose that in this first one, they've told us that the angle formed here is 28.3 degrees and that this vector happens to be 35.8 units long. Okay, so what we're going to do to find, in this case, the horizontal component, and remember what I've said before, is that the horizontal component is this direction. This is the horizontal, okay? It's like an X. And the vertical component is this one, the one that goes up, and it's like a Y. Okay, so that's what we're looking at here. All right, so in the first problem, number 5, it's very simple. All right, we've got the alpha, the angle being 28.3 degrees, and the magnitude of the vector v is 35.8 units long. So what we're going to do to find A, the horizontal component, is we're going to take the magnitude, 35.8, and we're going to multiply it by the cosine of 28.3 degrees. And again, you should use your calculator. Okay, I wouldn't expect anyone to do this without a calculator. And you're going to get something like this. A equals 31.5. Okay, which makes sense because if you think about it, you know that the angle is somewhere in the first quadrant, so the horizontal and vertical component, for that matter, should both be positive. But we're only looking at the horizontal component here. Now, what we're going to do is we're going to take a look at the vertical component in the next example. So here in problem number 6, we're given an alpha equal to 36.2 degrees, and the vector v magnitude is 242 units long. So the vertical component will be this part of the formula right here. All right, our b value, give me 1 second here, switch pens. Our b value will be equal to the magnitude, 242, times the sine of 36.2 degrees. And this on the calculator gives us something like b equals 143 units. So that right there would be the vertical component, and in the previous problem, the horizontal component. So there's not much to it. All right. Of course, when you're dealing with a diagram like the one here, makes it a lot easier to figure out. So using that principle, then let's apply it to some other examples. All right, we're going to write these two vectors in the form AB with the horizontal and vertical components. So again, what I'm going to do for you here is I'm going to write down what it is that we're looking for. Let me write it off here to the side. The A component, so it's AB, remember, is the magnitude of the vector times the cosine of the angle, and then the magnitude of the vector times the sine of the angle. And that's what the horizontal and vertical components would look like. In number 7, we have a magnitude of 5 with a cosine of 20, and a magnitude of 5 with a sine of 20. And again, you're going to punch that in your calculator, and you're going to get something like to 2 decimals 4.70 and 1.71 from my calculator. Now we're going to look at problem number 8, another simple one. Okay, so again it follows the same formula that we set out over here, and we're going to get 11 cosine of 140. All right, and 11 sine of 140. And it looks something like that. Okay, so what do we get? Okay, let's see here on the calculator. We get negative 8.43 and 7.07, which again makes sense. We knew that the x was going to be a negative and the y value would be positive. Okay, and that's exactly what happened. So these right here are the vector representations, okay, of these vectors where we were given an angle and a magnitude. So if this video was helpful, as always, be sure to like and subscribe.